In a lab at the University of Arizona, we conducted an experiment where green and red glow stick dyes were run through an emission spectrometer to answer the question of what emission duration depends on and does not depend on. Emission duration is the length of time the light is being emitted. We were given the hypothesis that emission duration observed in glow sticks is completely dependent on energy input and completely independent of the emitting fluorescent dye. Our data led us to the conclusion that emission duration depends on energy input, or for this lab the activator, and ionization energy differences between the dyes. Energy duration cannot be seen on the emission spectra, which only records emission intensity at specific wavelengths. In order to measure the duration, you must repeatedly put the substance in the spectrometer until there is no detected emission from the substance. As the energy input or the activator increases, more electrons are excited. When more electrons are excited, the emission intensity increases. When emission intensity increases, emission duration increases because it would take longer for the molecules to emit more of the absorbed energy. This is because as energy is being put into the system, or in this case the activator, the dye molecules are able to absorb that energy and continue emitting those photons which they absorbed. When there is no more energy being put into the system, then there are no photons being absorbed or emitted by the molecules. To put this in more relatable terms, imagine a wind-up car. The more a person winds up the car, the farther it goes. This is similar to energy input. If more energy is put into the system, the longer the glow stick will emit light. Another factor affecting emission duration is the unique ionization energies of the green and red dye molecules. We can see this from the hot water bath test in the lab. After we put all three dyes in the hot water bath, the red stopped glowing first, followed by the mixed dye, and green dye was still glowing even when our lab ended. From this observation, we can see that even though each dye was given the same amount of energy input as provided by the heat of the hot water, green's emission duration was longer because the energy required to absorb and emit photons is higher. Through the emission spectrum, we can see when the dyes stop emitting photons because the line will be at the baseline with no peaks, indicating that there is no emission from the dye. If a molecule has a higher ionization energy, then it would emit photons for a shorter period of time. Knowing that ionization energy, or IE, is directly proportional to the energy needed to excite an electron, it requires more energy for a molecule with high IE to absorb and emit photons. Given the same energy input for the red and green dye molecules, the molecule with higher IE will absorb and emit a fewer amount of photons, which means it will be emitting photons for a shorter period of time. Anyway, that's our video, and thanks for watching!